Hello everybody and welcome to the third and final day of Formnext 2020 Connect. We are here live again in the Sintratec headquarters in Bruck, Switzerland, and as for the last 2 days we created a fantastic program for you, fully loaded with lots of action. Just briefly, we are here in the Sintratec Experience Center. Usually this place is packed with Sintratec customers, packed with Sintratec visitors, everyone who would like to get hands-on training on our 3D printing systems. And here you can basically use our Sintratec S2 starter cells to print your own 3D printed files. Because of COVID-19, it's of course not possible to welcome visitors any longer. We decided to set up these special events to be as close to you guys as we just possibly can. Good, so we have a fantastic program for you today, loaded with lots of action. We have 3 live sessions. Number 1, we will prepare a print job on the Sintratec S2 starter cell. Secondly, we will have a look at how the laser sintering machines are performing live in action. And thirdly, we are depowdering Sintratec PA12 parts to make sure that you see the entire production cycle and to bring down the barriers a bit, maybe of know-how and knowledge to show you as much as we just possibly can from our SLS technology. All right, as I said before, this place is usually packed, but today not. Nevertheless, I have a small amount of my fantastic team with me who have helped to create this outstanding event. So we have here on the right side supporting me Ramona, our marketing manager, who will take care of the online chat function on YouTube. So feel free to interact with us, feel free to ask all the questions that you would like to have answered. We are trying, as yesterday and the day before, to answer all of them. If there's not enough time, we will put them into the chat. Good, we have Pascal with me who is supporting us well for our special event today. And afterwards we will see Andi and Thomas and Alessandro. All right, for the last 2 days we had fantastic special events, but there's nothing that is going to top the event of today. So today we will see if we can compete with plastic against metal. This means we will print on our Sintratec S2 starter cells one of these construction hooks, and me and my colleague Pascal will then personally go into a Swiss certified fitness center to see about how much weight we can load on this hook until it bursts. This is the first part of the event. The more important, the more impressive event is then we will go live onto a Swiss construction site. We will place our Sintratec PA12 sintered hook live on a Swiss construction crane, and we'll see how much weight we can lift until the hook will burst. All right, besides or between the live sessions, we have 2 fantastic technology talks. The first talk is with our lead engineer, Mr. Stefan, who will explain you about how we see creative possibilities on changing surfaces on 3D printed parts. It's a fantastic technology talk, so please join this one as well. And later on we have from the United States of America, Mr. Alex Hussain, who is one of our Sintratec certified partners. He's based in Florida in the United States, and he will tell us his opinion about the COVID-19 situation. He will tell us about how this affected the 3D printing industry in the US market, and he will give us a bit of a future outlook about where the direction is or where the possibilities and chances for these technologies are lying in the future. Good, so let me accompany you then and bring you a bit closer into our Experience Center. This is not just the Experience Center, we have a small amount of our 3D print service machines here as well, that our customers and visitors can get hands-on training and print their own parts out and do this live to see about how this technology works. Good, we have Andreas with us today. Andreas, hello. Yesterday and the day before we had Dario with us, but he was celebrating his birthday. So Dario, hello from the headquarters. Hope you enjoy your day off today, and Andy is fantastically taking care of this event today. Good. Andi will load the machines live, that you will see how the technology actually works and if it's really dirty or dusty, about some of the rumors that we already heard in the past a lot. We're going to just break them down and particularly answer all of the questions that you have. Good. Andy, let's have a good event.
Thank you.
Good. Then here we have our 3D print service plant manager, Thomas. Thomas, say hello. He's helping us in setting up the print of today. And in the corner over there in the boardroom, we have our fantastic Alessandro, who is basically responsible to make this event work together with our dear colleague and creative director, Mr. Alex Hussain, the person who is behind the camera. So yeah, thank you very much for all of you guys to making this work. Good. So let's start into the first live session. Thomas is preparing the print job of today. So you see, we have this hook of metal. Can you see this one? All right. And we are now placing and printing exactly the same hook in Sintratec PA12. This means we will one by one have the battle plastic against metal then later on. And you see that it's pretty easy basically to load these parts that you have created or that you designed into a house on Sintratec S2 software. So basically you can import the STL file. It's important that it is an STL file. You can place it in this virtual cylinder, which is basically representing our Sintratec S2 print cylinder. And Thomas, is it complex to do that?
No.
Well, I mean, this is not just a marketing answer, it's really not complex. So you load in the parts, you just mark the ones that you would like to move, you place them in the cylinder. Can you please give me the upper part? So maybe this view, yeah, you see this shape, sorry Thomas, is representing the Sintratec S2 print cylinder, and multiple parts are placed there. For action and speed purposes, we will just print one of these hooks, because usually the heat up time is 30-45 minutes. And yeah, I think it's important to give you a live glance and a live impression about how this goes. Good. So after the parts have been placed, you can do an analysis if the quality of the files is good or not. So this is basically our Sintratec Central, our house-owned software that our R&D and software engineers have been developing. It's Swiss-made, and you see here the first interaction to check out if the surfaces and the quality is good enough of the print, and if there's no problem going to occur because the print file is maybe broken or corrupt, or a shell is not closed or something like this. Is that correct, Thomas? All right, good. So let's go to Andi then and see how we load this file into the system. So Andreas, I'm going to moderate because I have the microphone. We need a bit of a distance according to COVID-19. Good, so we will now set up this hook printed in PA12. And Andreas is now loading the system. Maybe you will see that we have two print containers here on the left and on the right side. Both of them we are filling with Sintratec PA12 print-ready material. I will later on explain you what print-ready material particularly is. And yeah, please go ahead. So we have a 4K camera system and a control display which is guiding you step by step to this process. You just choose the file that you want. So usually users have multiple files on this system as well. You choose the material you use. It indicates the height that it is. So it's about 32 millimeters of height, correct? And then you can actually start the process. So this on-site manual is basically guiding you one by one through the entire steps that you need to take care of. And please be aware, we are using a Swiss high-tech system that is assembled and built in Switzerland. So this is really Swiss quality, Swiss made. It's a high-tech system, so please take care to follow a few of the steps that are very important, that you can get the best quality out of these machines as well. Good, please.
Can you maybe summarize again, Gabor, what the S2 is actually consisting of, to start the step?
Yes, of course. So Andi, let us just finish this one first. So you see every step is guided by checkboxes that you have to click to make sure that you wear safety, masks and gloves. I'm going to grab my ones as well. So basically afterwards we can go into the starter cell pitch. All right, I think first we are going to watch how we load the system, okay? And then we do the short introduction about the cell itself. So Andy, yeah, please let me support you if I can.
Okay, thank you.
Good. You see now that we are loading the system with Sintratec PA12 print-ready material. One of the questions that we usually have, is this process messy, is it powdery? You see that we have 8 high-tech ventilation systems on the back of the system, which are sucking the powder away from the front. Correct so far, Andy?
Yes.
And in addition, we have this anti-static cleaning solution, this vacuum solution that is basically sucking the rest of the powder away. Good. So you see that we have now filled these print cylinders. It's very important as well that in the middle part, correct, we are filling the cylindrical part as well with powder. And if you can just put the vacuum off. Yes? Thank you. Then you see now that Sintratec PA powder is placed in this in the print room, in the print containers, and Andy will use now the spatula to dense the powder a bit. Thank you very much, Janek, for supporting me. And you see that this powder is so thin that it's almost behaving a bit like, I think, water or mold. Huh? So you have to shake it a bit that it sinks down and creates the best possible surface quality at the end of the day. This is a very important step for the entire print process. Good, and after this is done, we fulfilled the next step. Andy can just put on the check mark. The green parts mark the PA12 printing ready powder. This is done. Good. We used the spatula to create the density of the print containers, and then if we mark all tasks done, the coater will start to move. Ja, kannst checken. The coater will start to move and will create this equal surface on the top of the print. Now you see there's a bit of inequality left as well. So this means we have to put another 3, 2, 4, 5 layers of PA12 powder on it. Then it creates this fantastic bed. Or is this okay like it is, Andy?
I would say it's pretty much okay. Just make sure that it's very flat and evenly. So if it's not evenly, or if you have any like scratches in the surface, just clean the coating blade. This is very important.
Okay.
This can happen due of residues, but if it looked like this, then it's pretty much okay, I think.
Good, great. So usually we're soaking away the bit of the rest powder over there, and then the print preparation is already done. Is that correct?
Yes.
Good.
Let me also say again, if people have questions, they can of course ask us.
Yes, so if you have any questions, please feel free to write them or to type them in the chat, because Ramona will pass me these questions and I can live answer them for you.
Maybe for people who want to see the whole workflow, do we have content for that as well?
Yes, of course. So for those who just tuned in now, we have an entire Sintratec S2 workflow video on our website, www.sintratec.com. We will have fantastic customer use cases there and multiple stories where you can easily dig into the technology and get more experience of it. Good, so the preparation part is finished. We mark the check boxes, process finished, done, we can leave. And now we can detach this lower part of the system, which I'm going to explain to you later on, from the material handling station. Is it okay if you assist me then?
Yeah, sure.
Yeah, sure. Yeah. No worries. Good, so you're just lifting this part because I'm assisting the camera guy with the cable.
Thank you.
Pleasure. All right. Good, and then we can just move this so-called material core unit into the, just 1 second before we do that, into this laser sintering system. So what you see over here is basically the Sintratec S2 starter cell. You see, this is not a desktop system, this is not a benchtop system, it's a semi-automatic standalone solution. And from our perspective, the perfect application enabling system to start easily on a average price investment and then to scale up your production according to your capabilities or needs. Good. This is the Sintratec S2 material core unit.
Let's see the surface again.
Yes, sure. This is the Sintratec S2 material core unit. And this one we are moving now in the Sintratec S2 laser sintering station. Is that correct, Andy?
Yes.
Good. So again, laser sintering station, material core unit, totally separated to avoid cross-contamination. This means if you have multiple of these material core units, you can easily use this system in an economically sensible range. So, and then if we just push this handlebar down, Andy can show us the rest of the process. The preparation is done and we can now start the print. Is the hook in the... Good, so you can just demonstrate how it goes. Yes?
That's pretty.
Excuse me, you have a question?
Yes, we have a question.
Yes,
So we have.
Maybe wait on it. Just wait a second.
we have a question from the audience. Yes, please.
So is this a changeable filter mat in the back of the material station?
Yes, so if you mean this part, yeah, it's a changeable filter mat. We can have a look at this here because the other machine is in action, so you can just easily open up this part, and this filter can be and must be, of course, after a specific amount of usage and time changed, because this is sucking away the powder for you, but it's basically pretty easily done. So fantastic Swiss high-tech engineering design, easy to adapt and to change. So I hope I was able to answer this question, Ramona, and please just interrupt me if you have more, okay? Good. So now you can see we have put the material core unit into the laser sintering station. Andi will now choose the print. So this is the hook. Again, this is the hook that we are creating today, not out of metal, we do it of plastic. Good, so then it indicates or is asking us the question, has the camera and laser glasses been cleaned? I can show you and demonstrate you this afterwards. Yes, we did. You just push the check mark and the process starts. You see the lights are indicating green now, they're shining in green. This means the laser sintering machine actually comes to life and starts to sinter. Is that correct? Good. So first of all, we have a very short heat-up time of about 30 to 45 minutes, depending on the environmental temperature. This is pretty fast. We are heating up now the entire material in this material core unit to its perfect temperature. This is approximately
About 45 minutes.
about 45 minutes of duration and about 170, 180 degrees of temperature we need in here to start the process. You see the height of the print, it's 32.3 meters, and this was the first part of our live demonstration session. So we showed you the print preparation in the Sintratec central house-owned software, which was designed and engineered by our software engineers. We showed you about how to fill the material into this material core unit with the support of Andi. Thank you very much for that. And we have attached the material core unit to the laser sintering station. Both are connected now and the sintering process starts. So in the second live session in 3:30, we have a deep dive and look inside of how the machine is sintering and how the process works. And yeah, thank you very much, Andi. This was it from your side. See you later then. Good, and just briefly to give you the full outlook again, selective laser sintering technology, Sintratec S2 starter cell. Basically, this system contains 3 high-tech machines. This is the laser sintering station, this is the material core unit, and here we have the material handling station. This all-in-one semi-automatic solution comes for a starting price of approximately 40,000 euros, excluded peripherals and material. Good. Any other questions at this stage?
No, we are good.
Good, we are good. So then just let me maybe...
Talk a bit about parts, maybe, what we can get out of this.
Yeah, I think so. Let's start with one of the most impressive ones. So what you see here is Big Al. Big Al is a dinosaur that was living thousands of years ago close to Bruck in Switzerland. And this is a reconstruction. So this entire body of this dinosaur was printed in one Sintratec S2 material core unit. You see, these are hundreds of small parts that are sometimes attached to each other, others not. And they are cleaned with love and intensity from one of our employees, because this is really fantastic to see about how thin we can basically do these prints and how we can make this assembly work, that it is really actually living and looks like, yeah, well, the skeleton of a dinosaur in a history museum. Good. On this side, where I would like to motivate you as well to visit our website, we have fantastic customer industry use cases. We have cases or customer use cases from huge industrial corporations like Geberit Switzerland. Geberit is using our technology since many years now, or Roger and his team from Geberit are using it to create rapid prototypes that are basically going to be mass produced then with a different technology. But I think the most important point in this prototyping phase is to make sure that you have fast time to market with the designs and parts that you are creating, to increase the speed of the engineering process, and to make sure that you from one day to the other can change the design, print the parts out, and then you have it live in your hands. So theory and practice are coming together to create the best possible result for the company. We have fantastic use cases as well. This is one of my favorite ones from Fabrizio from Fabrics. This is a spin-off of the UCL in London. So the team of Professor Simon Gaisford, and they are basically using our technology not to sinter PA12 parts or TPE parts. They are basically sintering medical material. This is something like paracetamol, I think. And what you can see on the video over there live, which is on our website as well and on our YouTube channel, so please follow us, are creating fantastic shapes of medical tablets in our selective laser sintering machines. They started with one and now they are using multiple ones to make sure that their research and engineering is going on fastly. Good, we have crazy shapes and designs that many of our dear industrial designer customers are printing, like this fantastic bike. Is this on focus?
Now it is.
Good. So this is really crazy. You can see how thin this is, how thin the structures are. And this is a design from Mr. Stefan Henrich, whom we had a technology talk yesterday. He's a fantastic designer in Stuttgart. So he really is pushing basically the design boundaries on the level of selective laser sintering, and he's one of the experts in the industry. So I can just recommend to anyone who has a specific need for an industrial design to get in touch with Mr. Stefan Henrich and his team, because he's really doing a fantastic job. Good. We have customers from educational and research institutes like Professor Alberto Ortona, who is basically printing these complex forms, these gyroids, exactly. They are not using this as an end part. They put over a ceramic paste afterwards and burn it out in the oven. And what is the result of this? You can see on our website in the SUPSI, the SUPSI story, in our customer stories section. All right, maybe let me just briefly give you a bit of an outlook about what other parts we can see here. So this was one of the customer use cases. We had a fantastic talk yesterday. This is from the E-Tech project and the team of Tobias Oesch, who are basically creating parts for e-mobility bikes. So this is the display holder of an electronic motorbike. A fantastic design and customer use case study you can watch on our website as well. E-Tech, awesome. Then, of course, in this situation when COVID started, we had lots of prototypes for medical parts as well, unfortunately. We have complex designs, for example, for a customized mouse. So this is really a mouse that is basically being pushed over a usual mouse. Yeah, there's nothing else I can say about this. And this was the compliant mechanism we showed yesterday. So this is a fully working, complex 3D printing mechanism. And of course, if someone is asking us, how big can we print with selective laser sintering? Please have a look. The question is, how big can you think? Because this part, this sword in this particular case, is printed out of one single Sintratec S2 material core unit. And if you take the attention away from the sword and can imagine that this could be a supportive tool for a service engineer who maybe doesn't want to climb up the ladder every day, then you can easily use a tool like this one to detach a part like a fire alarm or something and change the batteries. All right, good. So briefly maybe the history of Sintratec itself. 2014, excuse me, three fantastic electronical engineers started to dig into selective laser sintering technology and decided to create a machine which doesn't come for 250,000 euros plus. They decided why not try to engineer a system that comes for 5,000 euros approximately. And this was the result. This was the start of Sintratec itself. This is the world's first and still famous and never copied Sintratec kit. This is an assembly kit. This means for all technology enthusiasts, if you invest in this system, which comes nearly for the price of a good mountain bike or a camera system, 5,000 euros, you have 3 to 5 days of fun. You assemble this system on your own, like a Lego assembly set. And then you have the entire knowledge about selective laser sintering that you need to start to dig into this technology. Then we have had the Sintratec S1. The S1, we have a few machines left, but we do not produce it anymore because it just came to the end of its product life cycle. When we launched the Sintratec S2 starter cell, basically the orders just exploded and the request for S1 systems was no longer given. And we have, of course, a few simple peripherals, like this Sintratec blasting station and the Sintratec polishing station. This means in session number 3, in the live session number 3 today, you will see how we are depowdering parts. And sometimes after the process, we blast them as well. And to create a more shiny surface, we do polish them in this Sintratec blasting and polishing station. Good, so I think this was the first part of the session. Ramona, do we have any questions left?
No, there are no more questions.
All right, good. So the next part then, Janek, do you have something you want me to answer?
Maybe can we just say what materials we offer currently?
Sure. So at this stage, we are offering Sintratec PA12 parts. These are mechanically very strong and resistant parts, as you will see today in the showcase on the crane, in the fitness center and on this industrial crane, where we're really pushing the parts onto its limits. And we will have, I mean, this is maybe the best demonstration part, Sintratec TPE. So a highly flexible part. This is an example from ETH Zurich. Hello to the guys from ETH, by the way, which is just perfectly showing about how flexible and sensitive you can do this. Pascal, clap. Good, Pascal was holding it. Yeah, so I think this was the first part of 3 live sessions. We covered print preparation, we covered how to load the system itself. The next part of the program is the technology presentation and talk with our lead engineer, Stefan, who is again presenting you fantastic possibilities and outlooks on how to change surfaces, surface designs, or implement surface qualities, different kinds of, on Sintratec PA12 parts. All right, good. So I hope that you have enjoyed this first live session. Stay tuned, the program will continue soon, and we will be back live at 2:30 to see how the laser sintering process in the uploaded machine is basically working. All right, see you soon then.
Too many days in the darkness without a glimpse of the light. Running tired and broken and scared, but I swear I'll never give up the fight. I see you broken and beat, head pulled down over your eyes. Every part of you wants to surrender, but darling, you were meant to survive. With every star, we are born again. Open your heart and spend less time in your head. With every star, we are born again. Open your heart and spend less time in your head. Just like a seed in a garden, you will grow to be tall, staring out over miles of land without it, but wanting to build up walls. Lift me up in your branches, we can watch the sunrise. Just a couple of bruised up souls that believe that it was worth one more try. With every star, we are born again.
Hello from Sintratec and welcome to the keynote about 3D surface textures for additive manufacturing. I'm Stefan and we will spend the next 15 till 20 minutes together about this interesting topic. And first I would like to show you some applications of textures, followed by how do we create surface textures, and at the end, what do you have to consider when 3D printing. So let's start. You may ask yourself how we get aesthetic looking parts out of black material powder. So as you already know, selective laser sintering is the perfect solution for functional parts with complex geometries. But how we can jump from production into quality end-use parts with this plastic black powder material? So there are a few different opportunities you can use for a better appearance. For example, there are several surface treatments like dyeing or spray painting for coloring your parts. In combination with the black material powder, we recommend spray painting where a thin color layer is applied on your part. Another post-processing method is to polishing. With the Sintratec polishing station, small needles will peel the surface of the part and get a slightly darker and brighter surface appearance. And the third option is surface texturing, and that's the topic I would like to tell you more in this keynote. So let's start. To give you an idea what application you can use in combination with 3D printed texture, here are a few samples. For example, decorative surfaces. With the benefit of additive manufacturing, you can imitate surface textures like wood, fabrics, or also leather, for example. An additional advantage is usually surface finishing are added at the very end of the manufacturing process. With the benefit of additive manufacturing, you're able to integrate these textures and structures into the product development process. That means you can easily release different appearance and structures on the same part without interruptions or additional costs in production. Another application of 3D printed textures can be haptic surfaces, where friction is needed, for example. Think about a shift knob in a car, like here on the picture, or a knurling screw to tighten something into the production. Or another interesting example is the knurled lid on a PET bottle, for example. That makes it easier to open and close your favorite beverage. So that's also a good example for haptic surfaces. The third example are performance surfaces for flow control, for example. With the 3D texture, you can generate turbulence flow, for example, and improve the performance of your aerodynamics. You might ask yourself, why does golf ball have dimples? These small spheres in the ball. The reason is a golf ball with dimple flies almost twice as far than a golf ball without. So when I think about it, 3D texture can make me or us to better golfers. That's great, I think. So I hope I could give you a good overview with these applications, and now we talk more about how we modeling these textures. So the first step is to choose a design tool. Here are a few listed. If you are a mechanical engineer, I think you are very common with SolidWorks, for example. In the 2019 version, they provide an easy-to-use workflow to apply surface textures to models. Another software, for example, is Topology. It's a generative design software which has the goal to exploit the full potential of advanced manufacturing techniques, to make it more easy to use in the workflow in the software. The third option, it's Blender, for example. For me, a good software solution to start with and gain some experience, because it's for free, as it is an open source software, and there are plenty of tutorials available thanks to the huge community of Blender. So after choosing the design software, you are able to modeling your part. Think about areas you would like to separate from the textures, as it might be useful for if you have a counterpart which has to match properly and fit accurate. Or for example, a hole where you want to place a screw in it, where you want to have a flat surface, for example. You also can modeling your own texture on a two-dimensional surface. That's very easy, but it becomes more advantage if you have a surface like freeform or curved or spherical parts. So how we get this applied on a 3D freeform surface? The basic on the most 3D textures are a 2D black and white image. Like shown on the screen on the left, for example, geometric patterns, or on the right, more organic wooden or stone patterns, for example. There are plenty of those height maps available on different platforms on the internet, for free or for a small fee. If you have chosen one of these 2D black and white image, you can, or according to the grayscale of the pattern, a three-dimensional surface will be generated. According to the grayscale means if you have a white area, it keeps in place, and we have a black color, it will be displaced by 100%. So by assuming a strength to this coloring, we generate a three-dimensional texture. Depending on the software you use, there are several workflows available to apply the two-dimensional textures on your model. So in SolidWorks, for example, are different mapping styles, like for cubes or spheres or cylinders, which makes the pattern more consistent on the edges, because a smooth edge transition is very difficult to achieve, because you have to see, or you have to adjust the texture size, for example, or also choose a pattern which is a bit more, which can hide irregulation. Another example to apply surface textures are UV mappings. So UV maps are the 2D representation of a 3D model. Think about it like a piece of sheet metal before folding, or a paper sheet of origami. The unwrapped surface makes it easier to attach the two-dimensional black and white image to it. And thanks to the unwrapped geometry, there are less intersections if you apply it to a cube, for example. Let's talk about the mesh size. So the mesh size is also very important. If you want to have an accurate surface texture, you need a high resolution mesh. But be careful, high mesh resolution means also a bigger file size of the step file. So depending on your computer, we recommend a file size between 50 and 100 megabytes. So these are all the parameters you have to know about when you're modeling 3D textures. And now I would like to tell you more about the 3D printing. So selective laser sintering belongs to the family of powder bed fusion. And that means we have a fixed layer height of 0.1 millimeters. That's very important to keep in mind when placing your part into the powder bed. To give you an idea why the set resolution is very important, here is an example of a part of a sphere. So on the left, this sphere is placed horizontal with a very low resolution, with only 3 layers in high. If we place the same sphere in a vertical position, we gain a much higher resolution with approximately 11 layers thickness. So that's very important. Here is another example with a stone structure. So if we have it printed flat on the powder bed, you can clearly see the layers step by step. But if we print the same texture in a 45 angle, there are no noticeable layers visible. To give you a summary of the design rules, here a repetition. So number 1 is try to avoid flat textures on the powder bed, so because you have a low resolution appearance. The second rule is place them in a high set resolution, even if it takes a lot more powder and the printing process took a bit longer. And the third rule is if you have several faces in different angle, try to place them equally so that the appearance is in a similar look. Yeah, I'm very thrilled about this amazing technology about 3D texturing, and I hope you're creative now too with surface structures and have a lot of fun. Thank you for your attention. Do you have questions or this interesting discussions? Yeah?
So if I have something like a file and I would like to do also like surface on it, but I don't have any of these softwares and maybe I don't know how to use them. So can I contact Sintratec and maybe they are doing this for me?
Yeah, of course you can contact Sintratec, or also there are plenty of tutorials available on YouTube, or contact Sintratec, of course.
So maybe another question, have you designed all this surface by yourself, or how was the idea behind doing this?
Okay, the question was if I have did I created these surfaces and by myself, and how? Yes, I created this by myself with Blender, the open source software, and it took me a few days to become familiar with the tool, but at the end, yeah, I'm very happy with the result and it was a lot of fun. Okay, thank you very much for your attention.
Good, we are back in the Sintratec Experience Center in the Sintratec headquarters in Bruck, Switzerland. And first of all, we would like to answer a question which came into the chat. Is that correct, Ramona?
That's correct.
All right, so please assist me. Distance.
Justin is asking, how do you manage the moisture content in the powder? Is it a significant issue in terms of printing quality?
All right, I'm just repeating the question that you can all hear it. Justin Keating, thank you very much, Justin, for your question. How do you manage the moisture content in the powders? Is it a significant issue in terms of print quality? Good, so Justin, let me answer you like this. No, it's not, because the machine works like a devaporizer. So in the heating process of the system, because we heat up the material to the perfect print temperature, the moisture, the small amount of moisture which is inside of the powder, maybe it just evaporates. So this would be the correct answer to your question, Justin. And if you have any more questions left, please do not hesitate to interact with Ramona. All right, good. So in the first part of this live session this afternoon, we have basically prepared a print job. So we showed you how we place an STL file in the Sintratec central software. We showed you how we do print preparation, so loading the material core unit with powder to make sure that the process can start. And then we started the laser sintering process of, let me just have a look, of this hook, which is not going to be sintered in metal, it's going to be made in plastic. All right, so in the meantime, the heat up process already finished and the machine is sintering live. Again, I'm having with me my wonderful colleague Andi today. Andi, how are you?
Fine, thank you.
Good, so let's have a look. In this Sintratec S2 central laser sintering system, we have a 4K camera display. And on this display, we have different kind of possibilities to check out. So here we can see 4 different zones of temperature. Okay, we have surface temperature, we have the build cylinder temperature, we have the preheat temperature and the dome temperature. So Andy, can you maybe support me in explaining what the surface, build cylinder, preheat and dome temperature basically are standing for?
Okay. Well, I think the most important, or one of the most important temperatures is the surface temperature, because this temperature, how to say, is there for a good print. So this temperature is very crucial regarding warping, for example. So if you have warping parts, then you need to increase the surface temperature, for instance.
All right, thank you. So we have the surface temperature, which is basically the temperature of the top layer, I think. Is that correct?
Yeah.
Good. We have the build cylinder temperature. This is the temperature of the entire print cylinder itself. We have the preheat temperature, which is what?
The preheat temperature is for when the print heats up. So this is the temperature the surface needs to achieve when heating up. So and this is for dehumidification of the powder itself.
All right, and the final one is the dome temperature.
Yes, so the dome temperature is also there for maintaining or for helping maintain the surface temperature of the surface, yes.
Good, so thank you very much. You passed the test, therefore, I think. And now let's have a look about how the print is going on and how it looks live really. This is on our 4K camera system. This indicates and shows you exactly live what happens now in the machine. So again, we are printing now a hook. So we are printing basically this metal hook in industrial polyamide 12, in Sintratec PA12. And you see that now the coater has been moving and put on a new layer of powder. And as soon as the perfect temperature is given, the laser starts to burn or melt, or how we call it, sinter the surface together and creates these complex forms and shapes. Good, so again, the coater puts on a new layer of material of powder, and then the laser starts and the perfect temperature is reached. This is what you have seen before. And you see this is not speed up or slowed down. This is live, so this is real time. Huh? So one layer has been finished. The Z-axis moves up 100 microns. The coater puts the new powder over the layer, the laser indicates and starts to burn, and this is how the entire process takes place. And this is how we layer per layer are sintering now flatly this industrial PA12 quality hook. Is that all correct so far, Andy?
I would say so, yeah.
Good. So in the meantime, we decided, like yesterday and the day before, to show you not just the sintering process. We are now showing you the sieving and mixing process as well, because the Sintratec S2 starter cell is basically covering multiple functions for our customers. So it's a semi-automatic system, and we are now going to the Sintratec material handling station. Sure. Just give me a second. Yep. That's it.
Yeah.
That's it. All right, so we are here now and we provide for you live sintering, sieving process, excuse me. Good, so you see the manual on the screen indicates and shows you exactly step by step what you have to do. So on the right container side, we are filling in Sintratec PA12 used material. This is an important process because we are mixing used and virgin material together again to make sure that you have an economical cycle and can reuse the material which was not sintered in the sintering process. So the orange part again is the used material. This we need to sieve first and mix it with virgin powder. And then this mix ratio of 70% used material and 30% virgin material creates then the so-called Sintratec PA12 print-ready powder. And yeah, this is not a complex task. It's basically automatically showing you what you have to do. We have here this very clever system of an industrial sieve, which is basically being moved and shaped by an engine. And you will see that the powder corns that are good to be reused, they're falling down into the container here. And the rest, the particles which are not ready to be reused again, they stay over here. It's a very, very small amount. And this one you have to, of course, throw away then according to your local governmental guidelines for industrial plastics. Good, so Andy, please go ahead. You see we are using basic tools like the sieve. We are filling now, or Andy is now filling Sintratec PA12 used material, so the orange one into this container. He puts a bit more powder on the surface than he has to because he has to use this spatula, excuse me, he has to use this spatula again to shake a bit into the powder that it sinks down and becomes as dense as needed. And then in the middle cylinder, actually where the print range is, we are filling Sintratec virgin powder in. So this is the new powder which we need to create this 70-30, so 70 to 30-30 mix ratio. Good, again he's shaking the powder with the spatula. All right, you tell me when I can put off the cleaner. Good, and so now what happened, just briefly again, we put the Sintratec PA12 used powder in, we put the Sintratec PA12 virgin material, and this coater will start to put the powder, mix it already and put it over this industrial sieve, and then what falls down is basically then the mixed and created Sintratec PA12 print-ready powder. So a fantastic job by our R&D engineers. They really thought about a lot of things to make this step as easy as possible. What Andy is now doing is steering the platforms upwards. He already did the part with the spatula. The engine starts to shake. And maybe if you would like to zoom then onto the sieve, you see the coater now moves 2-3 times forward and backwards. Andy is putting a bit more powder on it.
And right away, how deep it lowers is the perfect ratio, correct?
Yes, so the system automatically indicates the perfect amount of powder you need to do this mixing process. So this platform with the used powder goes more down than the one with the virgin because it's 70-30 mix ratio. And now you see that the engine is shaking. I will just put over this. Can you see what happens? So basically it's shaking down and the corns that are staying left are rubbish or waste. And what falls down is basically the used and virgin material mixed, sieved Sintratec PA12 print ready. Correct so far?
Yes. I think now we could answer some questions.
Yeah, Ramona, do we have questions? Oh, we have a question in the chat, so shall we maybe...
I will stick on the...
Okay. Yes, Ramona, what is question?
So the question is, instead of using spatula, why don't use a vibrator? Maybe ultrasound or electromagnetic.
All right. This question comes from a gentleman called Vardan Tayesh. I hope I pronounced it well. So thank you very much. The question is, instead of using spatula, why don't use a vibrator, maybe ultrasonic or electromagnetic? Thank you for this question. We decided to use a very easy tool that is basically common for everyone. It's less expensive as well. It's less of an aero part as well, which can break down. So with this spatula, we really had the best experiences, and you have seen how fast it was possible to do that. But I will pass this question afterwards to the R&D department as well. This is the answer that I can give you so far. And then we have a second question again from Mr. Vardan Tayesh. Thank you very much. Will injecting inner gas in laser chamber increase the strength of laser adhesion? Not in this system, because we are not using any kind of inner gas in the Sintratec S2 starter cell. So this is really how you see the system is operating autonomously. We do not have any gas in this system. We do not feed the bed with gas, with argon or anything else. Because we are sintering industrial polyamides, in this particular case Sintratec PA12 or Sintratec TPE, and therefore we do not need to do that. We know that other systems need to, or are using this one, ours we do not, because our customers basically did not require to have this option. Yes?
And on the first day of Formnext Connect, I think I had a great talk about exactly that topic by our CTO, right?
That is correct. So Mr. Vardan Tayesh, I hope I pronounced it correctly, on the first live event session day, on first day we had a specific technology talk with our CTO and co-founder of Sintratec, Mr. Christian Vonburg, who explained a lot of details about this machine and the process, and some of the information that you have questioned now you can find being answered there. And please use our website and go to our YouTube channel to watch this program with our CTO again, and you will get deep dive insights about this technology, which will basically more or less answer the majority of your questions, I hope. Yes. Good. So let us go back to Andy. Do you have more questions?
No, not yet.
Okay, good. So we have no more questions now. Later on for sure. Good. So again, just briefly, semi-automatic solution. The Sintratec S2 starter cell. We have a laser sintering station, a material handling station, and a material core unit, coming approximately for the starting price of 40,000 euros, depending on what you need else. And you see, sieving, mixing, all done in this system. So this is the perfect application enabling solution to dig in fastly and easily into selective laser sintering. We are covering all three topics: laser sintering station, material core unit to transport the powder from one station to the other, or the print, and then the material handling station to do what we called the semi-automatic depowdering afterwards, which Andy is going to present us at 3:30 then. Good, so this is what happens. Again, Sintratec PA12 used, Sintratec PA12 virgin, automatically sieved, mixed together in this print container. Good.
Do we still have time at this time?
It's 5 minutes past.
Okay. Maybe we have some more time. Maybe we can show again the clips from yesterday. You want to talk about that?
Yes, absolutely. Let us go to this system then. Thank you very much, Andy. See you later then.
just to showcase how much we maybe trust that our own technology. Right?
Exactly. So what you see over here is basically these sliders on these alumide profiles.
Hold on.
Yes, excuse me.
No, not your fault.
Can you see it?
No. Let's go. Now it's it.
All right. So these systems are developed, engineered, and manufactured in Switzerland. This is really Swiss-made, so Swiss quality. To show you about how much we trust the strength of our Sintratec PA12 parts and its great possibilities, these sliders on this alumide profile, what you see, are some of the parts that we are printing on our own Sintratec S2 starter cells. And as I stated in the beginning, what you see here is the experience center and the small amount of our 3D print service machines. We have more, of course, but this is where we usually do the technology onboarding for our clients. So, coming back to the point about the trust in terms of the quality of the parts. So these sliders or gliders on this alumide profile are exactly these ones.
So they're built into our own system, right?
Exactly. So we are using the technology, of course, to wherever we have small, mid-sized productional needs, where it doesn't make any sense to create special tools or injection molding forms, for example, because we do not have thousands or millions of parts to do so. We print these gliders for Sintratec S2 starter cells on our own. And you can see this is exactly the same part.
I think it guides if you close it down, right?
That is correct. I can demonstrate this just briefly. So I will leave this one over here.
So these are mechanical end-use parts. They need to be stable, right?
Exactly. So this is basically when the material core unit is inside of the system. These are the gliders, that are basically pushing down the laser sintering station and connect them with the material core unit. So this is when I put these handlebars, exactly, you can see that these are our own gliders that we have created out of Sintratec PA12. So whenever a small, mid-size or serial production of parts that don't have to be produced or needed on thousands or millions, we do not use injection molding forms, which are basically pretty expensive to do for these amount of parts. We, of course, can produce them economically with our own print farm. And big advantage, we can easily change the design if we see an improvement from one day to the other. Okay. Good, so maybe another important topic or question I would like to hyphenize is why is the print cylinder circular and not rectangular? I'm just coming back, give me a second. Good. So again, for those who tuned in now, the Sintratec S2 starter cell is a Swiss developed, engineered and manufactured high-tech system. So Swiss made, Swiss quality, we have a laser sintering station, we have a material core unit and we have a material handling station. This system altogether comes for an approximate starting price of 40,000 euros, depending on what peripherals you need. And one of the questions was, why is this print range here, Janek, if you can come closer please, circular? And I'm going to explain this to you in a second. Good. So basically what you can see here is this is a Sintratec PA12 print cylinder. So this is the entire height that a print cylinder has. It's 360 millimeters of height. The diameter is 130 millimeters. This design was done by one of our lead engineers, Stefan Noser. Thank you, Stefan, very much for that. And you can see that the surface is not rectangular, it's circular or cylindrical, exactly. And the reason for this is that we have much better temperature control in the print. From the thermodynamics, we can easier and faster heat up the Sintratec PA12 powder. So this means in 30 to 45 minutes, as we have seen live this afternoon, we can heat up the material to the perfect temperature. And whenever the question is how much fits into one of these print cakes, I can demonstrate it for you on the other machine. Janek, do you have enough cable to come with us?
That's right.
All right. Good. So I stated perfect for industrial prototyping, small, mid-size serial production. You can easily extend or expand your production capabilities by getting multiple of these material core units. And I will now open up this print cylinder. Are you on focus? Good. So how many small parts or mid-sized parts do fit in one of these print cylinders? So you see, this is live. This is not fake. This is the empty print cylinder. These are the amount of parts that are fitting in, printed on the Sintratec S2. So you see, I mean, if this is not an amount of industrial production quality and parts, yeah. So this is really what we are standing for. Yeah. Good. Any questions, Ramona?
Yes, there is one question.
Oh, we have a question, yes?
How does the top mate with the bottom electronically? Is there a plug or a connection on the S2?
Okay, we have a question from Nick from the United States of America. Hello, Nick.
Hi, Nick.
Pleasure to welcome you here for the second or third session already. So you already have been with us yesterday, I think. So the question of Nick was, how does the top mate, so the laser sintering station, goes together with the bottom, the material core unit electronically? Is there a plug or connection on the S2? Yes, I will guide you just straight away over here. So Nick, what you can see, if Janek can put this focus on, is this is basically the electrical connector. So here you can see the pins. And if I move this into the material handling station, on the downside, so here, can you see this, Janek? Yeah, or can we come inside? Good. Full action from our creative director for you, Nick.
Yeah, I can see it.
All right, are you in focus?
Yeah.
Good. So please move besides. And Nick, you have seen we have an electronical plug in the material core unit and on the material handling station. You just easily and smoothly put this material core unit inside. Again, it's not a benchtop or desktop system. It works perfectly and easily. And then you connect, and the material handling station and the material core unit are connected. Or if you set up the print, I will present it over there as well. It's pretty easy. It's fast. Looks like a bit like a teleshopping presentation, huh? And here now we are in the laser sintering station, and you see laser sintering station, material core unit connected, material handling station, material core unit connected. So this is how it works. Yes?
I think it automatically registers if it's connected or not.
That is correct. So at the moment you connect, the laser sintering station or the material handling station automatically connect with the material core unit, and you have a perfect operating connection which makes sure that the process can start. Yeah. Another question, Ramona?
Yes, another one.
All right. Nick, I hope I was able to answer your question. Stay tuned, I'm here for you.
So we have another question from Justin from Australia. Are the nylon parts UV stable, suitable to sit outside in full sun at say 40 degrees Celsius?
All right, so Justin Keating from Australia is asking us, are the nylon parts UV stable? They are black, they are not white, so from my experience I can say yes. I will check this out with the head of the R&D department to make sure that this answer is 100% valid.
He mentioned it in the talk on day one as well.
Yes, so he mentioned it in the talk on day one. So Christian, our CTO, made this speech, which you can look up on the day one live event. Yes, they are UV stable. And secondly, are they suitable to sit outside in full sun at say 40 degrees of temperature? I will look this up from my perspective. Yes, they are. Our CTO just wrote, yes, they are UV stable, of course. It's dark materials, it's not white. And maybe they can answer us as well on the 40 degrees. Basically, the sintering temperature is approximately 176 degrees. So there should be no problem that you can keep those ones in the sun at 40 degrees. And as you are from Australia, Justin, hello. I was living in Brisbane for a short amount of time as well, so pleasure. Good.
So we are good.
All right, and Arva SLX, nice action shot. Thank you very much for this.
Thank you.
Arva, okay, good. We tried our best. Yes. So I think we basically covered the majority of the topics. Now we can go back and have a short look about the sintering process again. Exactly, so for those who tuned in now, especially from the colleagues from the United States or America now, for Nick, you see that on this 4K camera screen, what you see now is live the laser sintering process of this surface. So this is not made up, this is not speed up, this is real time. The laser is finished, the coater puts on the new layer of material, zack. The heating system indicates when the temperature is reached and the laser starts to work again. So we have a fantastic 10 watt fiber laser in this system, which is Champions League in terms of the spot size as well. So I think from so it's really fast, and you can see, of course, you can say it's just one hook now, but for the presentation of this afternoon, we decided to do it like this. Coater, new powder, temperature control, laser indicates, starts to burn or to melt, or how we call it, sinter to surface together. So this is what is really happening live and in action.
You can tap, it's a touch screen, right? So maybe show that again.
Yes. So I can go off of the full camera screen, and you see here, this is a touch screen. We can check the temperatures. This is actually the temperature range. So we have the surface temperature, 178 degrees. The process is 30% finished. We can go to the live view again, speed it up. You see everything that you need to see on this screen. Good, so let us just briefly go back to the sieving station or to the material handling station. For those who tuned in, this is a live mixing and sieving process in a Sintratec S2 starter cell. Left or right side, Sintratec PA12 used material or used powder. In the middle, Sintratec PA12 virgin powder. The coater is moving this on this industrial sieve, which has a shaking engine on it. The sieve shakes, the rest particles, maybe this is important, Janek, you can zoom a bit closer. So this is here, what is the waste. So this one you cannot reuse, but it's a very, very low amount of this Sintratec PA12 powder, and what falls down into the container is basically the sieved and mixed and print-ready material then. All right.
What time is it? I think we're good.
It's 10 minutes before 3. Ramona, questions? Do we have one? All right, so let me just basically close this second live session then. For those who tuned in, one question was, can we show it live again? So this is the Sintratec S2 starter cell, laser sintering station, material core unit, material handling station, starting price approximately 40,000 euros, depending on the peripherals and the material you need. So perfect application enabling system. Invest, start in your own production, and then make sure that you can easily just scale it up according to your production capability needs.
So what's coming up next, Gabor?
Yes, so next I will just have to take on my headphones then, because we are going to have in 10 minutes, so at 3 p.m. CET time, we are going to have a talk with one of our Sintratec partners, Mr. Alex Hussain from 3D Chimera in the United States of America. So Alex is based in Florida and will discuss with me a few things about the current situation in the United States of America, about the impact of COVID-19 on the 3D printing industry, and maybe gives us a short outlook about these expectations for the future. So for all customers who tuned in, or for all visitors who tuned in from the United States of America, be back in 10 minutes. We will have Alex, our local partner, telling you about his opinion and experiences in the US. And yeah, so stay tuned, and I hope you enjoyed the show. Do we have another question, Ramona? Yeah. Good, so see or hear you then in 10 minutes, and I hope you enjoyed the show. Be back at 3:30, because then we will do live depowdering of Sintratec PA12 parts. So we have a live print cake, which we are cleaning and showing you, is it complex, is it dusty, is it dangerous or not, and this is all live then. And afterwards, the special event, as stated before, me and Pascal, gentleman over there, will test if our industrial PA12 hook can keep up with metal. For this, we go into a Swiss certified fitness center and we'll load as much weight as we can until the hook bursts. And secondly, we will take you onto a live construction site and we'll put this PA12 hook on a real industrial crane to see about how much weight can we lift until the hook bursts. All right, so thank you very much. Stay tuned, program continues, and see you later then. Hello and welcome everybody to this Sintratec Talk. Now we are joined by Alex Hussain of 3D Camera, our certified Sintratec partner from Miami in the United States of America. Good morning, Alex.
Hi there, good morning.
Good. So Alex, how are you personally doing today?
Doing all right, doing good.
Good. So for people who do not know 3D Camera or yourself, can you give a short introduction about yourself and what 3D Camera is doing basically?
Yeah, absolutely. So I'm the co-founder and CEO at 3D Chimera. We are a advanced manufacturing company based down in Miami, Florida. We distribute a wide range of equipment to our customers. So 3D scanners, 3D printers, 3D software. And we work with them on a consulting basis to help optimize those systems for their problems or challenges they have in their business. We also do some service work with that same equipment. What makes us unique is that we're all engineers here, myself included, so we're very, very technical. We like to get into the weeds on our customer applications to really help use this technology to really unlock the potential of what you can do with it.
Cool. So thank you very much for this introduction, Alex. Well, these days, you know, COVID-19 is on everyone's mind. So we hear frightening news from the US. Can you maybe as a local person describe the situation or what's your daily experience?
Yeah, absolutely. So, I mean, COVID definitely has changed business, that's for sure. Day-to-day life, I would say it's starting to get a little bit back to normal, but yeah, as hotspots pop up, it's always a bit of a scary situation. As far as the 3D printing business goes, it's one of those industries that I think is actually benefiting from the crisis as COVID has sort of taken hold. We've seen many of our customers, particularly those in small and medium-sized businesses, have their supply chains absolutely decimated. And what they've been able to do is adopt additive manufacturing to completely reinvent their business. And so while it's sort of crazy outside, it's been an interesting time for the business and an opportunity to work with a lot of newer organizations for our team.
Okay, good. Very interesting. So from your personal experience now, so these days you mentioned that the local production is maybe shifting or coming a bit back. Before in the past, we often relied on third-party countries where the value chains have broken down, and it's very important for small, mid-sized businesses as well to keep the pipelines going. So do you see these as a challenge to let's say, establish or do this shift in terms of making sure that the industry is able to do that, is able to use the technology, maybe the new technology, not the conventional ones?
Yeah, I mean, there's definitely a learning curve for organizations that are looking to bring in additive as a production methodology. So I'd say the vast majority of our customers, they're either like completely outsourcing to another country, let's say China or something of that nature. And, between the cost of duties and shipping and then just the crazy logistics of this type of scenario, those supply chains were sort of cut off. So in some cases, our customers had to almost like relearn how to make things again, which is actually kind of awesome for us because additive creates all these new opportunities for how you might like completely redesign something. So in some cases, their partners might have the plans for something and not be able to share that back. So there's a big opportunity to work in reverse engineering and not reverse engineering a competitor's part, but like strangely reverse engineering your own part. And in that scenario, these guys then have the opportunity to optimize the design, make whatever minor improvements they've been wanting to make for years. And they're realizing the benefits of no cost for tooling, right? So, on products where you're making a couple hundred or a couple thousand a year, additive makes a ton of sense, especially when we're looking at the SLS technology, and especially when your parts are kind of smaller. And so, we've been seeing a lot of folks who are willing to go back and redesign. In some cases, that means, building out a new skill set or improving a skill set in CAD. Certainly, it's learning a new tool, right? And especially in the case of SLS, almost nobody really has familiarity with that in their day-to-day business. Some folks have outsourced that, but before companies like Sintratec, the cost of it is like super prohibitive, particularly for small and medium-sized businesses. So sometimes these guys have experience with like FDM 3D printing, maybe like a small desktop FDM. But this is a real shift. It's like when that technology shows that additive has potential, but can't get the job done, that's where SLS kind of comes to the rescue and says like, okay, we can actually make production. We can make end-use parts. We can make beautiful finishes that are totally acceptable for end parts for sale in the marketplace.
Okay, that's interesting, because from our experience, we have witnessed some kind of a 3D printing hype for a short period of time, because many people knew the FDM printers, the SLA printers. SLS is more or less not in everybody's minds these days, but now with this unfortunately COVID-19 hype about what 3D printing can help and support into bringing parts locally and fastly back again, it was an interesting shift that we have seen as well. So we have seen other companies, for example, in Europe, like one of our customers, Materia in Italy, was basically used the Sintratec S2, so the laser sintering systems, to produce some kind of adaptional parts for masks, for breathing masks, if this is the right phrase. And this was a very interesting point from our perspective to see that print services, if you would like to call them like them, have made sure that apart from the huge machines that they already installed, they needed fastly some kind of an express service they have had to install. So was this something that you have somehow seen or experienced in the US as well, that people not just change the technologies, that they have been willing, to put on new technologies, to get the risk as well, to invest maybe new technologies, to make sure that they fastly can help to solve this big global crisis that we are having now?
Yeah, I think in the US, supply chains were like really just not ready for the COVID crisis, particularly in March and as we kind of went through, I guess, that Q2 time period. So lots of companies utilize additive to do all sorts of really interesting things, our company included. So, we were working on face shields, we were working on some of those like snorkel adapters that you're describing. Actually, really, really interestingly, one of the doctors that like invented those snorkel adapters, it's like literally in Miami, right down the street. So like he came knocking on the door, and we would co-develop a bunch of stuff with him. So for sure, it's been an interesting thing to see. But we're starting to see now are companies who are actually adapting their business to work with the crisis. So, for example, we have one customer who makes some type of a product that is like a lighting system that is normally like a headlamp. And what they've done is redesign their product to have this headlamp and also hold a face shield, right? And they're actually using SLS 3D printing to produce these parts. So they went through other iterations of refining this design, this headband, to hold their light, which is how they make money. That's their business. And obviously the market today, you need protection when you're using that light, whatever the case might be. And so they've adapted it to work with these face shields. And so, yeah, we're definitely seeing companies evolve and change in ways that we've never seen really any like external event like cause businesses to completely like retool what they sell. But with additive, I mean, it's literally like spend an afternoon and click a button and you have the new product. It's not like the old school where it takes 6 months or a year to bring a new idea to market. I mean, these guys are able to turn on the dime. And that's why I think we're seeing the interest, particularly from the small and medium-sized businesses. In the US, we have this idea of like pulling yourself up from your bootstraps and like really buckling down when there's a challenge. And the whole idea of the American dream is to like, dig your heels in when there's a problem and like, work your way out. And we're seeing these small and medium-sized businesses do exactly that. And that's like enlightening, or, like it makes you feel good as, just a citizen here, seeing that the companies are doing that, the people are doing that. And that, we're able to be a part of that by providing the technology that enables them to do that.
All right. Are there any governmental programs who are supporting these small, mid-sized businesses by investing in new technologies and making sure that they get this knowledge more fastly than in the past, maybe?
Yeah, I wish there were more. There are definitely some interesting programs that you can take advantage of at this time frame. So we're close to the end of the calendar year right now. So in the U.S., we have this thing called Section 179, which allows businesses to basically deduct the entire value of an equipment purchase off of their tax burden for the year. So that's super, super valuable for particularly small and medium-sized businesses that are evaluating their tax burden. It gives them obviously a de facto discount on their equipment by not having to pay taxes on those dollars. And it was always intended to stimulate the investment in business equipment, and that's working. In many states, there are like research and development tax credits. So if you're using an equipment for R&D, even if it's just for a percentage of your time, you can deduct, there's some mathematical formulas that vary by the states, but you can deduct that from your taxes as well. So there are those types of programs that are helping, but there's no like national program of like, let's invest in manufacturing in the way that we'd like to see. We do have some groups in additive that are ramping up a little bit. So during this whole COVID-19 crisis, there's an incubator group in the U.S. That's called America Makes, and those guys are like a nonprofit organization. And they're definitely sharing tons of information. They took the lead in coordinating and distributing all the COVID-19 relief and qualifying designs for approval with the FDA and through the National Institutes of Health in the US. So we're definitely seeing an increased amount of awareness there. But there's not like a fund that you can go dip your finger into and get some new equipment. Okay. I hope maybe that's something we see soon. But today we're seeing a lot of businesses who are fortunate to be in manufacturing and see some growth here through COVID, take those profits, if you will, and reinvest that in their business.
Okay, that's very interesting. That pretty much, apart from the governmental program, is covering our experiences in Europe or in Switzerland particularly. We have seen since the crisis started that especially the multinational corporations, so all of the huge ones, they have frozen their budgets for investments. And luckily, not just for Sintratec itself, for I think the entire Swiss economy, the European economy, the small mid-sized businesses are willing to invest and fastly get this knowledge to make sure that they will keep up to date when the crisis is over and have an additional benefit to offer to their customers. So is this, I think in the US it's called the Fortune 500 companies, isn't it? So is this something that you are on your daily work, if you call customers, experience as well then, that it's more or less the small mid-sized businesses who are taking over now, not the control, but the charge in terms of pushing these technologies inside of the country?
Yeah, absolutely. The Fortune 500 companies, they're a huge part of our business under normal years. So, we're a small team based out of Miami, but we have partnerships with great companies like Sintratec, and our product offering is somewhat unique. And so we are able to distribute to customers across the entire nation. Very often, I'd say maybe 25 to 30% of our business is tied up in Fortune 500 type of organizations. And we saw like a faucet turn off when COVID started. Like 100% of the funding has gotten frozen. The good news with those organizations is they're still planning to make investments. They're just looking into 2021. So they're still planning for growth, but a lot of those organizations have been very conservative in bringing staff back. They didn't have as much access to like some of the funding that helps small and medium-sized businesses in the beginning. Like in the US, we had a program called PPP, which is the Paycheck Protection Program. And that was super helpful for small and medium-sized businesses, even our business. But big businesses didn't have access to that. They had it more in the form of like tax credits and things, and it was less direct. They're being way more conservative about it. The small and medium-sized businesses, I don't think they're even buying to sort of like just be ready. They're buying and they're leapfrogging the competition. So as the big companies are effectively, surviving on their momentum, they're sort of asleep at the wheel. While the small and medium-sized businesses are able to come in and scoop up huge chunks of market share. So, we're seeing businesses that even just a year ago were like a one-man shop in a garage, expanding tenfold in terms of their capabilities to distribute products to their customers. because they're able to be agile, right? For them, it's an overnight decision. Like, one or two people on the management team make a decision and they're ready to rock and roll. I mean, a big company, you have dozens of people and, groups that have to make decisions, and even just getting all those people on a Zoom call is like almost impossible, much less like making a decision. So yeah, we're seeing a lot of momentum with those small, medium-sized businesses, and like I said, that's like super great. I mean, we understand that better than just about anybody, being a small team ourselves. So we're really able to relate, and in the service side of our business, we're not seeing that drop off. So on the service side, we do see our Fortune 500 customers, they continue to grow their business. So they're operating, they're just not investing in new equipment.
Okay, it's very interesting because the majority of our small, mid-sized customers, these are hardworking people who actually work their shift, and after the shift is done, on CNC technology machines or whatever, they invest a lot of free time in having fun and bringing passion on learning these new technologies faster. And this is a really, really fun part when people are calling at 8 p.m. at night and asking questions. I think this is really a heart leading thing. All right, so let's talk about selective laser sintering in particular. You and especially 3D Camera have been a Sintratec partner now for many years. So what do you think, where do you see the market developing in the next 1 to 3 years? Because as I stated before, FDM is mostly commonly known to everyone. SLA is very commonly known. SLS, from my experience, is something that people are still struggling to understand the differences. We are explaining them, of course, if we get around to. But we feel that more and more people now starting to do this shift, as you mentioned as well, from desktop or benchtop systems down to professional systems in a specific price and effort range. And what do you think about this? What is your experience?
Yeah, I think what we've seen is a dramatic shift of our customers from prototyping activities generally with 3D printing. And I think when you think about FDM, right, it's like particularly good for like kind of bigger parts that are in really low quantities, right? So like a large singular jig or a fixture or like a big prototype. FDM works fantastic for that, but you could be looking at, hours or days to produce parts. Whereas what we're seeing with our customers in SLS is really seeing a transition to end use parts, right? So actually producing the final product. And so in those scenarios, not everything is a great fit, but certainly when you're looking to print like a lot of smaller parts where you can fit hundreds or even thousands of parts in a single build overnight, that's a real game changer for what you can do in production. I mean, if you're producing 100 or 1,000 parts in an evening, I mean, that's rivaling traditional manufacturing and avoiding completely the tooling cost. So, we're seeing customers who are saying, for the cost of like one tool, I could buy an entire Sintratec S2 and do a dozen products. And like, that's amazing. And instead of doing a minimum order quantity of, 10,000 pieces and waiting 6 weeks, I can get the 500 I need tomorrow, and then I can move on to the next design the next day, and I can fill out my product offering with a whole variety of things really quickly. So I think we're seeing this hard shift towards end use production parts, which then opens up this whole interesting opportunity for like different types of post processing and finishing on the parts as well. So we know, of course, as people who work in the industry, that when you're taking out a nylon part out of an SLS 3D printer, they look pretty amazing right out of the box, right out of the machine. But there's so much more that can be done, and like we're exploring that like a lot here on our team. So we can't even help ourselves from kind of getting into the challenging applications. So we've been exploring things with ceramic coatings and with metal coatings and waterproofing, and looking at different finishing techniques when you're blasting the parts or polishing the parts, to really create this huge variety of finishes that can be done in an affordable way. So it's pretty exciting to see.
Okay, and if you must break it down into 3 bullet points, so where do you see the 3 biggest advantages in selective laser sintering, and where do you see the 3 biggest disadvantages with selective laser sintering? This is a question I'm often asked by my clients, and so more than happy to hear what you're thinking about it.
Okay, yeah, all right, way to put me on the spot there. So in no particular order, let's see if we can go here. So To me, really, the biggest advantage is the ability to print a large volume of parts in a very short period of time. So the fact that we can three-dimensionally stack parts inside of the build volume really gives us a crazy advantage that is almost impossible to wrap your mind around if you're really focused in the FDM or SLA world. So we find ourselves doing a lot of explaining to people that, you know, filling out the build volume and packing it densely is where you get the efficiency from, because a lot of folks approach this with sort of that mindset of like, I have a footprint and then I can build up or, you know, out from that footprint, but I can't build on top of each other and stack together. So, you know, if you imagine if you can print, you know, a couple marbles on a tray on an FDM printer, that's all you can do. But in SLS, we can put a whole bag of marbles and print them all together in the bag at the same time. And that's a pretty big difference. So I think the efficiency of pushing parts through is one key thing. One of the other places we see a massive advantage, I guess our second point, would be parts that are super highly detailed, and particularly those that have thin walls. So we have a lot of our customers who have like really small devices. Maybe they're like Internet of Things, right? There's like a lot of on-body devices. There's a lot of really small plastic housings. I mean, like tiny things with like, you know, number 0 screws and, you know, really tiny things that come together. And what's really neat about SLS is, you know, before the only option, they couldn't even prototype that stuff. They had to, you know, basically, you know, commit to tooling and get those things injection molded. And a lot of times, you know, you order those parts, I mean, the volumes got like astronomical because like justify the cost of shipping, you know, overseas, and to keep the vendors happy with super small parts, you had to order tens of thousands of pieces, you know, at least a pallet's worth of parts. And sometimes these guys are just starting out, you know, maybe they need only a dozen, and maybe they only need 2 dozen for their trial run, but they couldn't even get a prototype. And so those designs now, they're able to take that CAD, right? So they'll go open their SolidWorks or whatever. They don't have to worry about going in and changing the draft angles or the rounds or the wall thicknesses. Like actually, like basically every rule for injection molding is like amazingly perfect for SLS as well. And so we're seeing this really interesting transition for super fine detailed parts printing perfectly well on the SLS printer. So if the first thing is, you know, pushing out a large volume of parts, maybe the second largest advantage is to put really finely detailed parts in there. And the third advantage that we're seeing is that SLS parts are shockingly robust, right? Particularly out of the PA12 material. So there's all these super hidden mechanical properties about this that like even you guys, I mean, nobody's talking about. So like we have one customer who is printing PA12 parts and putting them in an environment where they're exposed to liquid nitrogen. And he called us and said like, hey, I put it in liquid nitrogen and slammed it with a hammer and it didn't break. Did you know that? We're like, no.
Okay.
I mean,
Love to see it then. Okay,
yeah.
That sounds like an amazing case study then, yeah.
Yeah, so low temperatures work great, right? As we know, PA12 works at high temperature applications. So, you know, we have customers who are doing under the hood applications in vehicles now, which is like crazy, right? In FDM, you can't even really do that without a super specialty material and a very specialty machine, much less a really detailed part. We're able to do that. So we're seeing guys that are starting businesses out of their garages with SLS 3D printing, and they're competing with the big guys. Right, it's crazy. Like you can go on like Amazon, and some of the products you're buying are printed on SLS 3D printers. Some of them on Sintratec machines, and they're competing with the big companies, you know, for actual, you know, functional parts. We did a test recently where we did this contest for the U.S. Air Force, and we were trying to optimize a part for strength. And that particular part we were printing, we had done an FDM 3D print with a glass fiber reinforcement because we thought, boy, that's going to be the strongest part. We make these like little test coupons that are kind of like a figure 8. We hang some weight off of them. We found that the straight PA12 part printed off of a Sintratec machine with like literally right out of our sample kit box was stronger than the part we had spent like, I don't know, we were on our 35th iteration of optimizing the design for strength. And like we were trying to eke every bit of performance out of it. In the straight PA12 part, no fillers, no magic, no special settings, was stronger right out of the box. So I think there's a lot of hidden potential there for strong parts, for high temperature, for low temperature, and you know all sorts of crazy things with chemical resistivity that people are just starting to get their heads wrapped around. And so the potential is almost limitless in what you can do. You combine that with like the idea of maybe taking into account lattice work or generative design, which, sounds great on paper, but if you try to do that on an FDM 3D printer, like good luck, like you're gonna be breaking away supports your whole life, and you're gonna have weak parts. That's not the case of what we're seeing on the SLS technology. So, crazy geometries, like that stuff that like your brain can even barely imagine, we can start to see that show up in the parts. And it really helps these guys to not only set their parts apart in terms of what they look like, but you get massive performance gains as well. So those I'd say are probably the three top things, I guess, right off the top of my head. As far as like, was it the disadvantages you were thinking about or asking about? So I would say maybe not a disadvantage, but just something to keep in mind, and that people don't always realize, is that when you're coming from an FDM background, you're often thinking about making really dense parts, right? Like if you wanted to make a sheet of something, you'd basically make it very thick, and it's going to have like a low density infill pattern on the inside, and that allows you to get like a lightweight part. Well, in SLS 3D printing, because we're basically sintering the powder, we're basically doing everything one layer at a time. So when you have a big blocky chunk of geometry, that doesn't work so good in the technology. So there's a bit of a learning curve there for folks, and I'd say that's one of the challenges that people have to wrap their head around. So if you're used to designing for, let's say, like a milling application or for an FDM application, you're going to have to rethink those design rules. The good news is that you get to like open up the creativity, not close it off. But the bad news is that like if you've got really chunky parts that have big, thick cross sections that work great in FDM, those might not be a one-to-one transition over to SLS. So, designing for the process is probably one of the biggest challenges, probably the biggest challenge, I'd say, right off the top of my head. Maybe the second thing might be the overall lack of material options out there. So in the FDM world, obviously you have the vendor specific materials, and those work good usually. But now we're starting to see all these big multinational plastics companies getting into the open materials game. And that's really very quickly ramping up the material options in the FDM space. In the SLS world, we're not quite there yet. So, while we have some machines like the Sintratec kit, which are basically completely open material systems, in fact, we have lots of people developing new systems today, there's not a great marketplace for open materials at the moment, at least in the US market. And so that's something that I think is lacking and can be a little off-putting to folks as they're entering the space. But I always encourage people to look even just at the basic materials we have with Sintratec. That PA12 is way more diverse than people think, as is the TPE material. You can do some really crazy stuff with those two materials that not a lot of people know. So we're always looking to you guys to help us bring out new materials and ramp those into the systems. And soon, I think we'll be looking to the open marketplace. I feel like COVID kind of put a damper on that. I bet we're all about a year behind where we'd like to be. And then let's see, what would be maybe the third thing? Well, I think there's a disconnect maybe that people broadly have with SLS 3D printing and thinking about the size of the machine. So often when someone's buying an FDM 3D printer, they're thinking about printing the largest part possible on that build platform, right? So if they're buying a printer that's got a meter build platform, they want to build parts that are a meter in size, right? And that's because you pretty much have to have the parts stuck to the build plate. Whereas in SLS, I mean, sure, you can print a singular part that fills the whole volume, right? But that's not where you don't get any real advantages over other technologies by doing that. Where you get the advantage is having a lot of smaller parts in that same volume. And so that's also a thing that people really have to kind of learn and wrap their head around. So it's not really a knock against the technology as much as it's just like a big piece of missing information out there that we really have to educate people on. So I always say SLS is great for a lot of small parts. It's okay for a few big parts. Whereas FDM is great for a few big parts, but is terrible for a lot of small parts, like almost impossible usually. So it's there's a trade-off, right? And it's not gonna be the same tool for every application.
So, Alex, I think we're coming to the end of this discussion. Are there any final words from your side about the cooperation with Sintratec itself, and maybe for other international partners, why they should become partners of Sintratec as well, or why it's worth to do it?
Yeah, sure. Yeah, well, first off, thank you for having me here. Super excited to share these ideas, and I hope that it's been educational for folks. Overall, our experience working with Sintratec has been really fantastic. The technologies are a real game changer. We have little to no competition in the marketplace for a printer at this level of quality and the price point that we offer it. And so, if there are other organizations out there who are looking to add products to their offering, I think you'd be hard pressed to find anything that's going to have the level of quality and performance, really the industrial performance that you can get out of a Sintratec system anywhere near the price points that we're able to offer that. And so, while it's great for partners to expand their product line, and I think it opens up huge amounts of opportunities and doors, it's also incredibly valuable for our customers as well. And it for those same reasons, it allows them to really leapfrog the competition. So when a big company is looking at investing in technology, we're often helping them to bring in a bunch of Sintratec machines, but sometimes they opt for a much bigger system. I mean, you could be talking about systems that are 10 or 100 times the cost in order of magnitude. So it's really a crazy difference. So for a fraction of the cost, you can be competing with those kinds of guys. So it's been great with this technology. It's proven to be our best-selling product this year. I think perhaps last year as well. And we hope to see that to continue to grow into next year and to really help a lot of these businesses around the curve here and come back to health here after this COVID crisis, which has sort of crippled everybody. So we're looking forward to seeing what our partners and our businesses can do here.
Okay, good. So thank you very much, Alex, for your time, and thank you everybody for tuning in. If you have any questions, do not hesitate to call us, write us an email, or contact us on social media. And of course, make sure that you visit Sintratec.com, and especially if you are from the US, that you go to 3dcamera.com to share some thoughts with Alex, or maybe take profit from this fantastic consulting that he's doing. Thank you very much for that. And yeah, stay tuned for more information about our virtual Formnext event. We are looking forward to welcome you there. And this was all that I could say today. Thank you, Alex, very much.
Thank you.
Appreciate it.
Thank you, guys.
Bye-bye. Bye-bye.
Bye.
Hello everybody and welcome back again to this third and final live session of today. So before we start and go into the depowdering process of the Sintratec PA12 hook that we have printed, basically we have one question that we should answer, Ramona.
Yes, we have one question to answer.
All right, so who was asking the question?
Yes. So it's Cyclone. Tidal Energy is asking, power rating is different between the Sintratec machine and gives different material strength results.
Okay, so the question came from Cyclone Tidal Energy, and it was, is the powder rating different between the Sintratec machines and gives different material strengths? So thank you very much, Cyclone, for this question. Yes, we have different laser power sources. So for example, in the Sintratec kit, and the S1 we have a 2 watt power laser, and in the industrial solution, the Sintratec S2, we have a 10 watt fiber laser. So this should basically answer your question. Good, do we have more questions, Ramona?
No, you're good.
All right, so we promised you for this third and last live event that we are now depowdering a live printed Sintratec PA12 part. This is a hook made of metal. And we are now going to have a look about this hook of plastic looks like before me and Pascal will go into a Swiss certified fitness center and afterwards on a Swiss construction site to check out the tensile strength power of this Sintratec PA12 industrial plastic part. Good. So let me accompany you for the last time today. So just very briefly, you see again, this is the structure and the form. This is live printing in the Sintratec S2 starter cell. You see that the coater, as explained before, is moving the next layer of the powder on the surface. It's heating up and the laser indicates and starts to burn, melt, or how we call it, sinter, so laser sintering each surface together. In this case, 100 microns particularly, before the part is then finally finished and comes out of the machine. And how this process looks like, how we do the semi-automatic depowdering, we will now check out again with our service hero, Andi. Andi, are you ready?
Yes, I'm ready.
Good. So before we do this, just briefly, because there was a gentleman asking about how the mixing and sieving process looks like. So here we are live sieving and mixing material in the material core unit. You see, in this powder container there is the used material, which is not waste. This is used and not waste material. In the middle we have virgin powder, and this coater moves to this industrial sieve. The engine starts to shake, and what comes down is the reused or recycled material we can reuse again for the print. And for those who are having or raised the question, it's 70-30. So the mix ratio is 70% Sintratec used PA12 and 30% of Sintratec virgin powder. Good, so we promised you in this live event to show you how this hook comes out of a Sintratec machine. Please, Andy, can you give us a short explanation about how this goes on before we start? This is a finished powder cake. The reason why we call it a powder cake is that inside of this powder cake, basically the part is placed. So what you have seen on the laser sintering system, the material is heating up. The part inside of this powder cake will be sintered, and then it's enclosed. And this is what we before called, it's not waste powder what is left, this is reusable powder which you can mix again. Is that correct?
Yes, that's right.
All right, so let us look how complex the cleaning process is, or even if not. And we will put the vacuum solution on as well. Good, so we do now, live and in action. Please a bit slowly, the depacking process. Good, we have different tools to do that. So basically the system shows you, please make sure that this anti-static vacuum solution is attached. Please make sure that the correct container of Sintratec PA12 used material is attached. And now we are very slowly, for the audience, Andy, please do not speed this process up, take your time, are removing or releasing the rest powder which we can reuse again with our pretty easy to use tools. Good, as you can see, you do not need specially expensive tools to do that. You can easily do this with a kitchen brush, I think. Andy, is it correct?
You can see it's being sucked in directly, right?
Yes, so we have an 8-zone high-tech ventilation system, which is sucking the powder away from the outside and it stays in the back. We have this anti-static vacuum solution, which is sucking up the rest of the powder. And now that slowly comes together will be this hook, but not made out of metal. It's going to be made out of Sintratec PA12, so industrial polyamide and plastic. As you can see, it's pretty easy with the gloves as well, Andy, to release the material, correct? And what looks like magic is, out of this powder cake comes an industrial sintered hook. Yes, we have a question. I'll be back in a second. Is it okay if I leave?
You can answer it.
Sure.
So, Vardan Tejash is asking, what is the layer height?
All right, we have a question from a gentleman called Vardan Tejash. Thank you very much, Vardan, for this question. So the question is, what is the layer height that the print container is moving in the Z-axis? This is 100 microns, so 0.1 millimeters. We can write it down in the chat as well, yes?
Good, thank you. Others are good.
Good, all right. Well done, thank you for the question. Please feel free to ask more and interact with us if you have some left. So how many of these hooks did we sinter?
Well, in this job we had 2 hooks.
All right, so we basically sintered 2 of these hooks. So for the first person who writes us an email at info@sintratec.com, we will ship 1 of these hooks for free to you. So use the chance and give us your address and you will get 1 of these selective laser sintered industrial PA12 hooks for your own testing. All right, Andy, that's an easy to doing process, isn't it?
Very easy, very easy.
Is it dusty? Like, do you have to wear safety goggles or something like that?
You have to wear a safety mask, you have to wear gloves, but you do not need protective glasses, no.
So, like the work environment where you have this machine, does it have to be specifically, like, do you have to pay attention to something specific when you put the S2 in a work environment?
Yeah, so basically we do not recommend it to keep it in an office environment, although many of our customers, they do so. But usually this is in a separated room where you have fresh air, that you can open up the window and make sure that you have a good, clean, safe air pollution as well. But otherwise there's nothing you have to take care of, because Andy is briefly finished with the print, so I can again show you just a bit of the system if you would like to.
Maybe we can show the nozzle as well.
All right.
You have on the vacuum thing. The nozzle.
Yes. May I?
Yeah, sure.
Good, so you see that here on this vacuum system, we have a nozzle that was basically designed and printed from our R&D engineering team. This is a design of Stefan. And because we wanted to make sure that small parts are not going to be sucked in, we did this fantastic design. So as a father, I can say for everyone who has Lego at home, print 1 of these nozzles, because it's not going to suck the toys in then any longer. You can just easily detach it and then clean this up. All right. Good, so how does the hook look like?
Yeah, very good indeed.
All right. So again, we have a hook of metal. and we have a hook of plastic. And I think in approximately 20 minutes we are going to test the strength of this laser sintered PA12 part, which was live sintered in a fitness center first, and then on a real construction site, industrial crane. So we
both together, so I can see it. Go.
Yeah, sure. Can I have the second one? Good. So as mentioned, the first person who writes us an email at info@sintratec.com will get one of these hooks shipped for free. All right, use the chance. And before we go and continue, Andy will put one of those into the blasting station. Thank you. So you see now the print is finished. So if you could come closer, Andi mach's neu blasting, polishing. Sorry, polishing. Exactly. So you see this hook is now printed and it's finished. The surface looks a bit powdery still, but actually it's totally sintered. And we will keep this originally. And Andy is now going to the Sintratec polishing station, where he actually lets this hook being polished by magnetic pins. I can demonstrate it for you over there. Question?
Yes.
Okay, just 1 second. So basically, our sensor, which we call Big Al. So greetings to my friend Al from New Zealand. If he sees this, I hope you joined this event. Big Al was printed in one Sintratec S2 print cylinder. It's a very complex dinosaur construction. It's about 400 parts, very small, very thin, all printed in one print shop. Of course, you have to clean it a bit more carefully than this one, because this is a very strong part, and this is basically, very thin wall thicknesses, so carefully to be done. All right, so Andy printed 2 hooks, and one of them, to make sure that you see the difference, is being put into a so-called Sintratec polishing station. So this polishing station is actually a magnetic tumbler, and when we started, these magnetic pins here are shaking and will create a smooth and shiny surface to make sure that the rest powder, after we blasted it and polished it, is not any longer on the system. Good, Ramona, we have a question.
Yes, regarding sandblasting, Cyclone is asking, are you not using sandblasting?
Good, so again, a question from Cyclone Tidal Energy came. And he was asking us if we do not use sandblasting. Yes, we do. So we have this small peripheral Sintratec blasting station. The question was correct, where we usually, for a big amount of prints, we use it to remove the powder or the final parts of the powder before we go into the polishing station.
For more complex parts, right? That have like holes.
Exactly, exactly. So for the smaller prints, we are using this blasting station because it's absolutely enough. And if you have a huge amount of industrial parts that we are printing with our print service or in our print service for industrial clients, we have a huge sandblasting system which does this automatically with a rotation. So with a rotational engine, yeah. Good. So it still takes a few minutes until this is done. Do we have any more questions, Ramona?
Another question.
Fantastic. Interaction is the best, so challenge us.
So maybe please can you just also mention where they can request samples from us?
Sure. So if you need any 3D printed samples, please go onto our website. We have a section there where you can use our print service, so you will directly interact with the gentleman over there, Mr. Pascal Frucci, me and my team. We are more than happy to create you samples and to print you samples. Yes, and we have another question I can see from Teja Vardan. Now I really need that hook and that dino figure. Good. So Vardan, because you've been, was he the first one that wrote?
Yes.
Good, so Vardan, congratulations. You have won this Sintratec PA12 printed hook. Please send us your contact details and your delivery address, and we make sure that you get this live printed part soon.
So also Tejesh would like to know, will change in printing orientation change the strength of hook?
All right, so the question is, will the change in printing orientation, so this means if you put this part like this, or like this, change the
strength of the hook.
change the strength of the hook? Yes, it will, because the z-axis is where the platform is moving up, and this is basically, in terms of the strength, the weakest part of the print process, because layer per layer is going to be put on, but it's not a huge, massive difference. But usually, if we print mechanically very critical parts, we put them in a bit of an angle, let's say 30 to 45 degrees, because then we have the smallest surfaces, basically, if you do the cross-sectional cut, and we can establish the best quality then. And I saw another question from Vardan. I would like to get the dinosaur here. Well, Vardan, I'm very sorry to tell you that this is something we cannot realize, because this is basically IP protected. So the gentleman, you can read this in our, on our website as well, who has sent us this data, was a professor from the United States, who basically participated as a consultant, I think, in the movie Jurassic Park as well. And therefore, we cannot send this away, because it would not make sense. It's so thin that even though if we would be able to do it, you know, if we deliver this with FedEx, it would, I think, end up then in a broken part that is not satisfying. Yeah.
I'm showing close of this really.
Yes.
Part of it.
Yes. Good. Any more questions, Ramona? Yes, please.
Am I in the way?
Yes, I just wanted to demonstrate one more thing. You're not in the way, but your cable is. All right, let me just release this one. Good. So just briefly again, for those visitors who tuned in now, what we have demonstrated for the last 3 days with fantastic live event and action events was the Sintratec Experience Center. We presented you the Sintratec S2 starter cell. This is basically the world's first and only semi-automatic system, which comes in the price range of approximately 40,000 euros, depending on what exactly you need in the configuration. Here we have a laser sintering station, a material core unit to move the material from one station to the other, and we have a material handling station. Swiss R&D, Swiss engineering, Swiss made. We produce these systems in Switzerland to deliver the best possible quality for our customers all over the world. Good, Ramona, we have another question.
Another question from Cyclone. Has the S2 process been certified regarding quality control by any auditor yet? In the kit, I got mixed results in the process.
Okay, so the question is from Cyclone, has the S2 process been certified? So we have a CE certificate on the system. I mean, this is basically what hopefully answers this question. And then we have already another one from Mr. Nicholas Cavanaugh.
Yeah. How closely do the material properties of your parts compete with those of traditional manufacturing techniques?
All right, so Nicholas was asking us, how closely do the material properties of your parts compete with those of traditional manufacturing techniques or technologies? Nicholas, thank you very much for this question. Lovely picture with you and the family in the background. I'm father myself, so I appreciate your question. Well, it depends what you are comparing it with. If you compare it with injection molding or CNC manufacturing, there are all techniques or technologies are different. Everyone has its strengths and advantages and disadvantages. So this would be something which we could more particularly demonstrate you if you send us a sample part. We can produce this one for you, and you can judge then the quality by yourself, because I'm not sure what technology you are relating to. But please feel free, do that, send us your part, we print it for you, you can check it out, and then you have the best transparency in the terms of judging the quality. Good. Ramona?
That's all, thank you.
Good. Please take down the note that Vardan gets his PA12 sintered hook. All right, just finally, before we go actually to the most thrilling and actually loaded part of today, testing this hook in a Swiss certified fitness center with my dear colleague, Mr. Pascal Fucci over there. See how strong this Sintratec PA12 hook is and how much weight we can load on or we can bear together in this fitness center or on this fitness machine. We will load in 5 kilogram steps, and afterwards, just straight afterwards, we will go on a real construction site to check out with a real construction crane about how much weight we can lift with this polyamide industrial plastic hook, and when it breaks. Good, so maybe two things which have been asked in the break. Again, I demonstrated how many parts fit into a Sintratec S2 print cylinder. So you can see here, this is the entire volume of a Sintratec S2 print cake. So this is 360 millimeters of height, or 36 centimeters. The diameter is 130 millimeters, all right? And it's a circular shape, it's not rectangular, it's important. And if you would like me to put on the focus, then do it now, Janek, because I will show you now approximately how many parts do fit in. I didn't fill it up until the end. You're on focus? Good. So let's see how many parts fit into one system, or how many parts you can produce. So if you would like to come closer. Good, so these are hundreds of small parts that we have printed basically in one print cylinder of a Sintratec S2 starter cell. So this is a huge amount. Of course, if you have bigger parts, less fit in, but if you use small parts for design, prototyping, mobile phone holders or whatever, it's a fantastic starting and application enabling solution where you can easily, for an affordable price range, start your production and then scale up with additional systems according to the production needs. All right, so what else do we need to cover, or what other questions do we have, Ramona?
Yes, we have another one.
Oh, fantastic, we interact, that's awesome.
From Pranav Patil, do you provide process simulation kit with machine to analyze build failures?
All right, there is a question from a gentleman called Patil Pranav. Thank you very much for your question, Patil. So the question is, do you provide processes simulation kit with which machine to analyze build failure printing defects? So basically, if you are a customer of Sintratec, you have access to the Sintratec customer portal. And every system has a so-called log file. In this log file, we can detect if something happens, what happened, when it happened, and how to solve your issue. So if you are, at the end of the day, or hopefully will become Sintratec customer, use the chance to interact with our service engineers, like Andy, who presented us this afternoon the entire process. They will be more than happy to support you and guide you step by step into this world of 3D printing and selective laser sintering.
So Justin also has a question. What is the print time for a full cylinder?
All right, Justin Keating is asking us, what is the print time for a full cylinder? That's a very good question. Justin, thank you very much for this. So this one, what you see here is 360 millimeters of height. Now it becomes a bit, we have to go a bit into the mathematics as well. The easiest calculation that is not 100% correct is for each centimeter of print height, you need approximately 1 hour of printing time. Now, if it comes down that you are not placing multiple parts into the build cylinder, maybe just one or two, you of course do not load the machine fully. And the best answer from the mathematical side is that per each layer, which is moving 100 microns upwards into the z-axis, you need between 5 to 45 seconds maximum to sinter a small amount of parts or a big amount of parts. So again, less parts, 5 seconds per layer, small amount of parts, 45 seconds. And then you have to calculate up until it goes. And typically, such a print cylinder would then take approximately 30 hours, so 30 hours of printing time. But whilst you are printing, the big advantage of the S2 system is that you can already, if you have a second material core unit just in, mix and prepare the material for the next print. And when the print is finished, you can open up the material handling, the laser sintering station, and you can take this print out after a specific amount of time. It needs some time to cool down in the system. And then you can move it. Besides, the material cools out, and in the meantime, you're already producing again. So Justin, I hope I was able to answer you this question. If you have more particular questions, which we cannot cover in this chat, feel free to organize a meeting with me. I'm more than happy to bring you live again, personally, to the Sintratec Experience Center. Good. Any more questions?
No more questions, no.
You want to compare how the polishing went, or?
Yes, Andy. Andy, is the polish part finished? Okay, so stop the process and just blast it off, then we can compare it. Yeah. So Andy is bringing us now the second hook we printed, the polished one. All right. So again, we will compare the original PA12 printed part with the polished one. Then we will go in a few minutes. Pascal, are you ready?
Yes, I am.
All right, we are grabbing our jackets and we will go out into a Swiss certified fitness center. So stay tuned. We are really giving our best to show you about how strong these PA12 parts are.
Wasn't finished, but it looks
Good.
quite good.
All right. So you can, oh, it's still pretty warm, huh? Good. So maybe you can see this already. Is this okay if I do it like this, Yannick?
Hold on, let me focus. Oh yeah, you can definitely see a difference, man.
All right. Original one, not polished. This one was polished now for I think 3 to 5 minutes. And if you, Wardal, according to your question, polish it for about 5 to 10 minutes, you see that it becomes totally shiny and smooth, and it creates this fantastic surface at the end of the day, which has, of course, a better design. Yeah, it's looking different and a bit better than if it's coming rough out of the machine. Yeah, this is it. All right, Ramona, any more questions?
Not yet, no.
Okay.
Good, so it's 8 minutes before 4. So let me just show you this one. Pascal and I will now grab our jackets. Please give us a few minutes of time. And we will go into this Swiss Certified Fitness Center to test this, or let's go into competition if metal or plastic can keep up with metal. So industrial polyimide Sintratec PA12 against usual metal. So good, Pascal, ready?
Yes, I am.
All right, grab your jacket. Stay tuned, we will be back in about 7 minutes, okay? All right. Good. See you later. Bye-bye.
Bye-bye.
Good, so you have seen actually how we have a selective laser sintered hook today, and we are now live in a, let's call it, fitness center, where we are demonstrating or trying to demonstrate the tensile strength of one of these hooks in this fitness center on a fitness machine. Good, so for this I'm having my dear colleague Pascal with me. Pascal, would you please be so nice to...
So what's the plan now? You're gonna...
Well, basically we are just trying with a very limited amount of weight first to see how it goes. And then we are trying to increase the strength by putting more and more weight on this hook. And let's see how far it goes before it breaks, or if it even breaks or not. So we are starting now on a very basic and low level with 5 kilograms. We are going to increase the weight on 5 kilogram steps each time. Good, Pascal, please give it a try. All right, this is going well, okay. Shall I increase it for you? Or do you? Good, so we are now on 10 kilograms as you can see. Still holding. All right. 15 kilograms. All right, now we are up to 20 kilograms. Good, so you see the hook is still intact and it's still working, it's not broken, nothing. Where are we, Pascal? 25?
25, yes.
25, okay. So this is what we as Sintratec Switzerland see as a very low level performance test for this hook, but we are trying always to transport the message with a bit of fun, and this is what we are actually doing. Pascal, where are you now? Do you feel the pain? Do you feel the pain already?
Yes.
Okay, he's doing pretty well. All right, still works. We are up to 35 now. Now 40 kilograms. Very good. You're still in shape. Okay, and you can see the construction is still holding. So it's still stable, and again it was selective laser sintered with industrial polyamide 12, so Sintratec PA12. Pascal, where are we now? 50 kilograms. Okay, 50 kilograms, still going good. All right. 50 what? 55. Okay, still holding. So you see it's still strong and didn't break so far. So we are up to 60 kilograms now. Basically, for safety reasons, I must inform you that you need a very basic level of sports and fitness condition before you do that. So we are now at 65 kilograms. Good. Pascal, is it still okay for you?
Yes,
A little bit shaky. Okay. We are now at 70 kilograms. So you see full power up for Sintratec and the hook. What was this? 70? Do you think we will manage to get on full weight? Okay, good. Appreciate your effort. So please.
We have to do it together.
Okay. So this was 75 kilograms. 75 kilograms that this selective laser sintered hook made of Sintratec PA12 was holding in an official Swiss certified fitness center. Okay, don't hurt yourself. Okay, this is enough. How much? 80. So shall we do it together then? Good, so you go on this side, I will go on this side. So we are going now up to
85.
There's Nali. 80. We need to share now the power to see that this hook is still holding. Pascal, you count down on 3. Men ik kan zoveel.
3.
Okay. Good. So it's 90 kilograms now, still holding, still not broken.
3,
3.
2, 1, go.
Okay. So you see it was 90 kilograms. I think we will get up to 100. So it's 100 kilograms now. 100 kilograms, Pascal, we don't have to hurt us. Go. Okay, good. So we reached the mark. Another 20 kilograms to go. So now it gets interesting. If the mechanical tensile strength of this part will still hold.
We go to 110.
110, okay. Okay. Good. So another 10 to go. We count down. 2 steps. Pascal?
1, 2, 3.
All right. So I think, as you have seen, we reached the absolute maximum and top of the weights in the Swiss certified fitness center that we have been actually allowed to use for safety reasons. So Pascal, thank you very much for accompanying me today with this test. And I think this was a nice shot and introduction to show you about how strong and how powerful Sintratec PA12 is, demonstrated with the hook. Thank you very much for your time and see you back in the Experience Center. Welcome everybody, we are here outside of the Sintratec premises in Bruck, Switzerland. And today we are actually testing how stable our Sintratec PA12 sintered hook is. So we have the grateful support of a local construction site team. Thank you very much for this. And now we are going to see about how strong this hook can keep this 400 kilograms of weight. All right. Gut, danke. 350, 400 Kilo, hè? En dat is tijdelijk hebben. Super. So thank you very much for the local Swiss construction site team. We have successfully completed our tensile strength test. Here with this brick of cement, which was basically 400 kilograms of weight. The hook was holding until a specific amount of time until he then just split off. Good, so this was it, and now I give back to my colleagues from the Experience Center to continue Formnext Connect. All right, we are back.
How fast are you going?
Yeah, so very fast. So at least one hook burst. You have seen this on the construction crane. The second one from the fitness center was actually holding. So we had a real life test, which is basically a very semi-professional tensile strength test that we did. Plastic versus metal, and I hope you enjoyed the show so far. And because this is, Pascal, can you assist me please? This was the final part of the event. This was the final special event we did for you guys. So herewith, I would like to thank you very much for all visitors of this live event, for all Sintratec customers, for everyone who interacted with us and gave us the chance to open up the doors of Sintratec a bit in this crazy pandemic COVID-19 situation. For me as the moderator, it was my greatest pleasure and I had lots of fun whilst these last 3 days. Unusual, of course, I had to wear a mask as well, so I hope the sound quality was good enough. And if you enjoyed the event, please drop us an email or write us in the chat. We would love to do more events like this. And before I will close the moderation, of course, I would like to say as well that if you have 3D printed parts you would like to have, we have our own 3D printing print service. We have fantastic Swiss quality, Swiss-made systems to start and to dig into SLS technology. And of course, for all students who have fantastic projects, if you would like to share your designs, if you can, send us the files, and if we can create a fantastic and nice story together with you, we will organize one of these special events for your part as well, to share it with the audience, to share it with the world. And I think this is the final part of my moderation. I would like to thank the entire Sintratec team. So this is a small part of the Sintratec team who made this fantastic event possible for you guys. And for me, it's the end now, or at least I will hand over to our CEO, Dominik Solenicki, who will have a few final words before we close this session, and wish you a fantastic Formnext 2020 Connect still. Stay healthy and best of luck these days. And if you need support in technology know-how for sintering, we are there for you. Good. Okay. Sorry.
All right, do we have sound? Hopefully, guys with headphones, now we're just not shocked. Next time we get more microphones. Okay, I have the easy part to just say goodbye. First of all, I have to thank Gabor especially. I think you had a presenter with a lot of action, a lot of passion of the last days. I've tried to watch as much as I could. Because parallel, we had the Formnext Connect, which is also now coming to an end. We hope next year we can actually see you in person as well. This year, yeah, we have COVID, but one thing we've learned is that such digital live events really can, be a benefit, especially for those who wouldn't have been able to come to Frankfurt this year, Germany. I hope you had some good insights on what we're doing. The team had a lot of energy and passion over the last weeks into creating this event. There's a lot of stuff that had to go on in the background. Special thanks here goes to Stefan Murawski, who will also be leaving Sintratec to travel around the world. We wish you a lot of luck. Thank you very much for your time with us. Special thanks to Pascal and also to Ramona, Vanessa as well from the marketing and sales team who helped organize this event. Who's not present today. Special thanks goes to you. Also to our service hero, Andi and Dario, who has supported the team hands-on over the last days. Again, I hope in the near future we can actually see you as well in person. Up until then, make sure to subscribe our channel. Now we can say this is Sintratec as well. Like and subscribe. And we'll be sure to make such live events in the future as well. Thank you very much. Thanks to everybody who participated. We had some awesome and nice questions. Thank you very much. I wish you all the best and have a nice weekend.
Super. All right. Good.